Hello everyone. Welcome to the part 4 of IT for biomedical students, biomedical engineers. You can even call that as a IT for non-IT people. So today's topic we'll look at what is an IP addresses, and we focus mostly on IPv4, completely on IPv4. So what is an IP address? An IP address, it's like a number, the numerical number we assign to every devices we have on the network. For example, here uh, we have three devices on a network. So each device is assigned with a number, which is very similar concept to what we have in our housing addresses in our locality. For example, let's take our street. It has a street name and it has our door number, right? So that's how if there is anybody wants to send a packages to us, so it comes through this. And there are more informations to it like a street in a country, but let's just take for this for now particularly. So you have a street address, street name, and then the house door number. Something like that. Similarly, on the IP addresses have a door number and then the street number. Together, it is given as a addresses. It's four octant address. We will look into it deeply what each number represent. So for now, you can take this as it's a numerical number or a label which is given to every devices like we have door numbers in our houses. IP address is a very important concept. This video may take longer than the previous videos, so please bear with me. So there are two versions of IP addresses available. So one is called IPv4, other one is called IPv6. We will not look at IPv6s here in this video or in this series. IPv6s are not widely used, and also when it comes to the medical devices or local area network devices, IPv6 are not used. So it's only IPv4, and that's more than enough for us to work with all the devices in the local area network. So how, for example, we're going to take one addresses. Let's take that 10.1.1.1. This is how an IP address is going to look like. But how do you come to this number, right? So what are the ranges of IP addresses available for us to use? If you see, it starts from 0.0.0, and then the next address is 0.0.0.1, and then it goes dot 2, dot 3, so on so till 0.252. It's actually 255. My bad. I'll correct it. It's 255. So it's 255. After that, it does not go to 266. This is the last number you can have. So the next address begins as 0.0.1.0. And then the next is 0.0.1.1, and it goes on 1.2 until 1.255. And then the next address is definitely not 266. So it should again go back to the starting like 0.0.2.0. And it goes on and on. And if you keep coming, and you will reach eventually 255, 255, 255. So if you take this one address as a count, 1, 2, 3, 4, like that, you will have these many number of addresses available for us to use in the local area network. Can we use all of the addresses? Definitely no, because there is a standard given to us and what block of IP addresses we can use. For example, we can use this block of IP addresses for something, for the local area network, and I will explain that in detail in the next slides. But there are addresses we cannot use, we are not supposed to use. For example, we can't use any addresses in the range of 0. We can't use any addresses which is like 255 255, which is will be a broadcast address. So for now, what I want to understand, what I want you to understand is this many number of addresses are available in IPv4, and these are the IP addresses, and in that there are block of IP addresses we can use it for our local area network, and there are other block of addresses used for the different purposes. So we're going to take one IP addresses and see how this IP addresses have come to form. For example, let's take this particular IP address 10.1.1.2. So if you take this IP addresses, it's equivalent binary. This is the binary equivalent. It is an 8-bit binary digits. So it has four different octant 1, 2, 3, and 4. So one of the reasons why it's called IPv version 4. So it has 4 octant, and then each octant is of 8-bit. So I told I in one of the places I said like you cannot go above 255, right? The reason behind that is this particular number will become 11111111. So this is equal to 255. That's the reasons you can't go further because it's only 8-bit. So 256 cannot come in this 8-bit. So then the next thing you have to do is you have to increment the second number. So then this one will become from 00001 to 00. So this is the equivalent of 2. So then this how it goes. So one of the reasons why it can't go beyond 255 is because it is an 8-digit binary number. You can't go beyond 111. So this is just an example. Will you be using this in your real life scenarios? No. And this is informations to good informations to know why this IP addresses are in this particular format, especially when I said, why it starts with 000 and why it ends with .255. So this is the reasons why this is happening because of this. So again, we are taking the same example of IP addresses, but this time we're gonna see what portion of this means actually. I'm sorry if I'm stumbling here. So every IP addresses have two parts. One is the network portion, other one is called the host portion. So you can take this as like this is kind of a way to identify which street you belong to, and this is something like to identify your door numbers. So you can assume like this, right? So if that's the case, in order for the packages to come, they need to know both the things, right? They need to know the state and they need to know the door. So the IP addresses have two portions. So this portion will define which network you belong to, and this portion will define what is your particular number. Together, it's your IP address. Together, it's your IP address, but there are two portions to it. One is the network, other one is host. How do you find which is network and which is the host? For example, in some scenario, this could be your network address and these two could be combined to could be your host address. But how do you find? There's a concept called subnet. Through that, we will find it. We are not going to discuss about the concept of subnetting in this video. I'll make a separate video on subnetting on the next part. That will help you define which portion of the network IP address belongs to the network, which portion of the IP address belongs to the host part. So how the network portion and the host part is decided, that's using the concept called subnet mask, which we will make a separate video to discuss. But for now, I would like you to understand that every IP address has together it has some portion dedicated for the network to find, and then there is another portion to find what is the host. So let's just take one particular block of IP addresses, one particular network. So this particular network, right? When we are taking the same example 10.1.1, in which network it belongs to? It belongs to this network, right? So what are the IP addresses we have on this particular network? So that is what we are going to discuss in this particular slide. So the first IP address of this particular network starts at 10.1.1.0, and then the second one is .1, .2, .3, .4, and then it goes on till .255. So out of this, you can assign all the IP addresses to any devices on your network. So if you do that, it means all of those devices are in the same network. For example, if this IP address is device 1 and this IP address is device 2, I'm just randomly picking it up. So this device is called device 3. This IP address you gave it to device 3. It means all these three, device 1, device 2, device 3, all are in the same network. So that's what we call it. Okay, all the devices are in one network. Can I use this IP addresses and this IP addresses to any of the devices? The answer is no. The reason is this IP address is defined. This defines that the name of this network. So when someone says 10.1.0, it means that is the network address. So this says that this has this block of IP addresses under this. So there is another addresses which I said you can't use it, which is this 10.1.255. That is used for the broadcasting. Meaning if anyone sends in packet to this particular address, it will go to all the addresses which is marked as green color. If you have any devices with this IP addresses, it will go to all the devices. So that's why it is there. So you can't assign this to any devices. So any packet which is sent to this particular addresses, which will be sent to all the devices which is mentioned in green color. If you see this particular block in green color, you will have total of 254 IP addresses. So the plus you have 1 and 2. So total there are 256 addresses you will have in this particular block. So in this particular network, I can say, can we cut short to, like, instead of 254, can we make it to 128? Because I don't want to waste all these IP addresses. You can. How? Using the concept of subnetting, which we will discuss separately in another video. For now, I want you to tell you that this particular one means you have a block of IP addresses in a same network. How it is in the same network? Because of this is starting with 10.1.1, and everything which is after this is host part is different. The network part is same. So that's how you find that this particular IP address block belongs to the same network. So let me just clear something here. So erase up. Give me a minute. Erase all ink on the sides. Okay. So this is a bit clear. So if you see how many network address we can have in this network 10.1.1, it's 254 as I mentioned before, because if you see the green colors, there are 254 addresses, and then plus two addresses are there. But these two addresses are not used for anything, because the first address is called network address. It's like you're saying this is a street name, yeah, something like that. So this is like the broadcast address, meaning if anyone wants to send data to all the devices in this particular network, they have to send it to this particular IP, so that will be sent across to everybody. If you want to send only one particular IP on devices, you can mention that IP addresses, like for example 10.1.71 as your destination address when you send the data from any of the devices. But when you mention your destination address as this particular point 255, that's going to send it to everybody. So it's going to go to everyone who is on the network. So I just kept this page for blank in case if I can discuss something about there are different blocks of IP addresses. So as we said, we just discussed one block which is for 10.1.1.2. What is the next block is available for this network? We can say 10.1.2.0. So this is the next block which will start, and this will end with 10.1.2.255. So whatever is there in this particular block of IP addresses, it belongs to this network 10.1.2.0. So you can use all of this. Again, you will have 254 numbers of addresses in this block, and then this is one and this is one. So as I said, now we have total 256 addresses on this block, and then the next block will start at 10.1.3.0. So this is happening because we are using a subnet mask of 255 255.255.0. So this is the subnet mask we're using to find out which is the network portion, which is the host portion. Don't worry about it. This is not the clear detailed explanations of the subnet. We will discuss that in a separate email. But my point here is you have 10.1.1 network here, and you can have 10.1.2 network, 10.1.3 network, 10.1.4 network, so and so, and it will go on and on. So that's the point here. Don't worry about it. This is a subnet mask it used, but we will discuss that later. I mentioned before that you cannot use all the IP addresses in the block. For example, I showed you this is the block of IP addresses. These are the blocks of IP addresses you have. But can I use all of them? Definitely no. How are we going to see that? This table, particular table, will explain you that. For example, there is most important thing is the private IP addresses. So these are the range of IP addresses we can assign to our devices in the local area network. So this is something every devices you have in your hospital or in your offices or at home will have it. At the same time, the same IP addresses will be assigned to someone in different hospital or in a different school. It doesn't matter because you are located in a different building. You have your own local area network. You can have your own style of IP addresses, either 192, 172, or 10, something like that. It's your internal addressing. So it does not affect if some people uses the same addresses in a different building, but it will affect if you two devices in the same building or the same network uses this IP address. So this is like an unlicensed IP address is given to us for our internal use, which we can use it for our devices. This IP addresses you will see widely. The next is the loopback addresses. These addresses you don't see much, but you will see them in most of the configurations. You don't assign this address to any devices, but what does it mean? It means it's local. So whenever this address is mentioned, it means it is pointing to itself. For example, there is a computer here. You have a data which want to send it again to you only. So in that cases, you use this address. You don't have to use this particular any kind of network addresses, because if you use that, it may go outside and come back in. But if you use 127.0.0.1, it does not go out of your PC, but it just gets inside your PC and roam between your applications. So this is pretty much used to tell, send this data to me, something like this. There is a block of addresses which is used for multicast. So whenever the destination address is in one of these, it means it is being sent to group of IP addresses. And another addresses is the public IP addresses. These IP addresses are given to you by your internet service provider. Mostly if you are in any countries like, I don't want to mention any specific countries, but in your countries you get a mobile services, telephone services from the particular companies, right? And they are the one who gives this IP addresses to you. So this is not something you can assign to your devices. So this is something which is given so that it's available on the internet. So it gets you to the internet. I mean, it's available on the wide area network. It gets you into the internet. So does it mean that these devices don't have internet? Kind of yes and no. Meaning, when this is an IP address for your device, let's take one IP address from this range, 192.168.0.5. So when this is an IP address of your device, one, can it access the internet? Yes and no. Meaning, if this is not connected to any router in your hospital, the answer is no. You can't. If it is connected to the router, the answer is yes. But what would be the IP address of this router? It will be one of these public IP addresses given to you by ISP. So that's how. So what happens is whenever the data moves from your PC, the device 1, and it reaches the router and it leaves and it goes to the internet. But when it leaves, the IP is changed from private IP addresses to the public IP addresses, which will be one of this. That concept is called network address translation. If needed, I may make one particular video on this particular concept. But for us, our focus is mostly on the local area network. We may not get involved with the network address translation, the NAT concept, or the public IP addresses. Our focus should always be the private IP addresses. These are the IP addresses we can assign to our devices. Okay. Thank you. So I just try to speed up, thinking not to waste your time. So if I've gone too fast, please let me know in the comment section or send me an email. So what we have seen is what is an IP addresses, what is an IPv4 addresses, what is the host and network portion in the IP addresses, what are the block of IP addresses we can use, and how IP addresses are numbered. So that's the most important thing we have seen. The network portion and the host portions are decided by using the subnet mask. The sub concept of the subnet mask will be discussed in the later session. If you have any questions, feel free to write me an email. Thank you. Thank you for your time.